Alright, this is 5.4 problem number 8. We're using the first part of the fundamental theorem of calculus to solve. We're looking for dy dx. And the information we're given is that y equals the integral from a constant 0 to cotan x of the function 1 over 1 minus t squared with respect to t. And so we're not going to be able to do this using the direct fundamental theorem, the first fundamental theorem, because this is not x up here, right? We talked about it last video that if it's from 0 to x, or any constant to x, we can just replace the t inside of this function with x, but because it's cotangent x, we're not quite allowed to do that. So we need to come up with a substitution. Well, let's go ahead and use u. We'll use u as our intermediary, and we're going to set u equal to cotan of x. Alright, so let's rewrite this. So now we've got y equals the integral from 0 to u of 1 over 1 minus t squared dt. Alright, so now I want to figure out what dy dx is. Well, dy dx, according to the chain rule, we could find that by taking the derivative of y with respect to u, and then multiplying it by the derivative of u with respect to x. You see, because the du's will cancel, and you end up with dy dx. So let's write that over here. I want to know what dy du is. Well, here's my y. So if I'm looking for dy du, I'm looking for d du of this function, right? The derivative of y with respect to u. This is y, so we want to take the derivative of this with respect to u. So 0 to u, 1 over 1 minus t squared dt. But then we have to times it by du dx according to the chain rule. And so we have to multiply this whole thing by du dx. Well, we can figure out what du dx is because we know what u is in terms of x. So du dx is simply the derivative of cotan x, which on your chart is negative cosecant squared of x. Alright, so now we've got this right where we want it because we have this going from a constant to a variable. The variable isn't x though, it's u, but we can still utilize that because d du of the integral from a constant to u of 1 over 1 minus t squared dt, according to the first fundamental theorem, we can set that equal to simply 1 over 1 minus u squared. Right, we just did a replacement where the t squared was, we plug in a u. And so now we just need to times that by du dx. And that will tell us what dy dx is, which is what we're looking for. So du dx is the negative cosecant squared of x. And now we're going to plug back in our u, which is cotan x, because we want everything in terms of x. And so with all substitutions, we usually plug back in the original. So this is going to be u squared is cotangent of x squared, which is cotangent squared x. And then we're multiplying through by negative cosecant squared. Negative cosecant squared x. And here's where some trig identities come in handy. So you can prove this to yourself using the Pythagorean identity, but 1 minus cotangent squared x is actually equal to cosecant squared x. So the denominator turns into cosecant squared x, the numerator turns into negative cosecant squared x. Well, it doesn't turn into it, it was already that. And so negative cosecant squared x divided by cosecant squared x is minus 1. And that's our answer, that we prove that dy dx is equal to minus 1. I know these problems are tricky. They're probably some of the most tricky that this class has covered so far. But I hope this helps you kind of see how to use a u substitution and what the first part of the fundamental theorem is saying and how it can help us cut corners. If you haven't seen my first video on the first part of the fundamental theorem, please do that, and it will explain why for this expression here, I was simply able to replace 1 over 1 minus t squared with 1 over 1 minus u squared. So anyways, I hope this helps, and I'll see you next video.